We are recording now. Hi again, everyone. Welcome to today's workshop, which is end-to-end data analysis in Python from raw data to insights. My name is Saba. I'm a fourth-year Bachelor of Computer Science student at Conestoga, and I'm specializing in big data and machine learning. I'm an executive lead at GDG, and I'm also the marketing director. I have experience working as a quality assurance analyst as well as a robotic process automation developer. I'm passionate about data science and just generally using technology to enhance the health and the well-being of people. And I'm really excited to welcome you to the world of data science in this workshop. I've actually included my LinkedIn as well as my Discord ID here in case you want to connect with me later. I would also love to even stay after the workshop today if you want to chat about something or discuss something. So please let me know if you want that. Okay, now let's dive into our topic. So today we will be having an introduction to data analysis. We will then talk about our mission today, basically what we are going to be doing, what is the data set that we're going to be analyzing. We will navigate through Kaggle and its main features. We will learn about data investigation and cleaning. We will look into data visualization, which is a very important part of today's workshop. And we will also talk about what's the next step after this workshop for you if you're interested in data science. I have actually included the presentation slides in a Google Drive folder. In addition to that, I've included a cheat sheet as well. If you want to refer to the functions and methods that we're going to be using, I will include the link in the chat section. Let me know if it's not working maybe for you. I can look into it. Yeah, if everyone's okay with that, we can move on. Okay, perfect. Thank you. Okay, now let's move on into data analysis itself. So in simple terms, data analysis is basically the process of taking a very big, messy pile of raw data and then transforming that into a story and into a knowledge that we can use. And we use this to solve different problems, evaluate how we're doing, and even predict how we're going to be doing in the future or what might happen in the future. So why is this very important and highly valued in our world? Well, first and foremost, it helps the companies, organizations, and people to make decisions that are based on facts, that are based on evidence, rather than just guessing. And it helps with business intelligence. And this means that understanding exactly what your customers want right now. It helps businesses track their performance to see if their current strategies are actually working or not. And it also helps in risk management and helps to identify the risks and the red flags before they turn into something big and disastrous in the future. Of course, we've heard how many applications data analysis and data science has, but I've included a few of the important ones here. One is in healthcare. You might have even heard of fields like bioinformatics, which uses data analysis a lot. So we use it in healthcare to maybe track patient outcomes, to help medical advancements, and just medical research to see how effective the treatments are, for example. We use it in finance to detect any frauds that are happening, maybe to see how the budgeting has it been effective in what we want to do in the organization, and based on that make other budgeting decisions. And it is also very useful in marketing, and I think this is the one that we're very familiar with, for example, with the recommendations that we get on Amazon. So basically it helps analyze the customer behavior, what they like, what they don't like, so companies can make decisions based on those. There are different types of data analysis, actually. There are four major ones. The first one is descriptive analysis. So descriptive analysis really focuses on summarizing the historical data, on looking into the historical data in order to understand what has happened in the past, what has been the trend in the past. And it provides a clear picture and a report of this. We have diagnostic analysis, and that explores data in more depth, determining why certain outcomes happened. And therefore identifies the causes, correlation, contribution factors. We have predictive analysis, which basically uses models as well as historical data to predict and forecast what is most likely to happen in the future. We have prescriptive analysis, which builds on the predictive insights that we had by recommending what actions should be taken next. And it provides data-driven strategies and solutions to basically optimize the decision making. And today, our main focus is going to be descriptive analysis. So in the world of data, there are various roles. And some of these roles actually have a lot of overlap. And here we want to understand what each role does, how they relate to each other, how they overlap, how different they are with each other. We will start with data analyst. So data analysts' focus is mainly on descriptive analytics. They interpret the past data, they try to find patterns and trends, and they use visualization in order to communicate their findings to the stakeholders. We have data scientists as well. So sometimes we can be confused between these two roles, but they differ slightly. So data scientists go one step further. They use machine learning models and algorithms in order to predict what is going to happen in the future as well. So they go beyond just descriptive analysis, and they look into the future. We have data engineers. We also have data architects. They're very related to each other, and they both specialize in the infrastructure. So a data engineer would basically focus on how they want to gather all this data, and then bring it into a location, a warehouse, so that the data analysts and data scientists, for example, can use these data in order to analyze them later on. So they basically work on this data pipeline. We have AI ML specialists. So you might think, how is this different from a data scientist? The AI ML specialists mainly focus on creating those models, and data scientists can actually use these models later on. And we have business intelligence developer, or BI developer. They actually also have a lot in common with data analysts, because data analyst creates reports through that visualization. So does a BI developer, but a BI developer focuses more on creating those dashboards that stakeholders really look forward to see how maybe the real-time data, the analysis of the real-time data. And we have the business analyst as well. And they are the bridge between the technical team and then the stakeholders, so the non-technical team. And they try to get those requirements from those stakeholders, so that the technical team, which can consist of data scientists, data analysts, can know what they have to work on, so what the stakeholder is looking for. And as you saw, there's a lot of overlap between these roles, and that's why in smaller companies, there can be maybe data scientists can do the job of an ML specialist as well. So one person can work as several of these roles. But the bigger the company and the organization becomes, really more distinct these roles become. And today, our main focus is going to be actually, we're going to act as a data analyst. So before we jump into the code, I wanted to show the workflow of data analysis in a very high level. There are more steps, but these are the main steps and what we're going to be focusing on today. First is the collection. So data collection, where we're going to get these data from. Is it just some files that we're gonna, for example, some CSV files, Excel files we're gonna use in order to analyze them? Are we scrapping the web? Are we getting it through an API? We have data cleaning, which is a very important step because the real data that is out there is really messy. It has a lot of fields that are missing, and we really have to handle these missing fields and clean this data before we start analyzing. We have exploratory analysis, which basically is we use visualization in order to understand the data, but this is mainly for the analysts themselves, so they can see how the data is, what information they can get from the data. So they play around with the data basically. And then once they do that and they know how they are going to get the answers of the questions that they have been asked, then we get to explanatory analysis, which is communicating those insights that they got clearly through charts and graphs to the stakeholder. So we did use visualization now in exploratory analysis to kind of see what is happening in the data set, but now we want to even create even more clear graphs and visualizations so that the stakeholders can better understand what we found. So what are we going to do today? We will be navigating Kaggle first, a very quick navigation, and we're going to set up our notebook environment. We are going to be using a real-world data set. We are using the Spotify data set today. And we will write some code in order to analyze this Spotify data set and then create some professional charts and graphs that tell our story. And yeah, these are some of the graphs that some of the charts that we're going to be working on today. So we have a scenario. I wanted to make this as close to the real world as possible. So the scenario is that you have been hired as a junior data analyst at a company called Hitmaker Records. And what the executives of this company wants is that they want to produce a popular song for summer of 2026. And they are the one that they have given you the massive Spotify data set. And your mission is to find what makes a song popular. So before even we dive in, I want you to open Mentimeter, and I want you to tell me what you think would make a song popular. So you can either use your phone to scan this QR code, or you can just go to menti.com and enter this code. And we're going to be using it throughout the workshop, so you can keep it open. And yeah, I'll give you a minute. If you need the QR. Okay, we got 3 answers out of 7. Two of you think that it's the artist's popularity. One of you thinks it's high danceability. It's interesting. Maybe we'll wait for the 4 folks. We have one other. I wonder what the other is. Oh, yes, of course. So here is the code. I can put it in the chat as well. Okay, I'll wait a few more seconds and then we can move on. So far, artist popularity is winning. High energy. Nice. Okay, amazing. Okay, so based on what we have so far, we can see that most of us think that it's the artist's existing popularity. We have one vote for the other ones as well, and I wonder what is the other option, person who voted other. But anyways, we can move on. Let me start sharing again. Okay. So let's look into Kaggle. So what is even Kaggle? Kaggle is basically an online platform that is for data scientists and machine learners to connect with each other, to work on different projects, to participate in competitions. It holds millions of public data sets on almost anything you can imagine. It hosts, as I mentioned, very big competitions. There are even very large prizes on some of these competitions. It also has a very big learning community. And you can basically, it has a lot, not only has places where you can discuss things like discussion posts, but it also has a lot of courses that you can look into and then get a certificate even. I've included the link for them here, but we're gonna go look into them right now. So if you can open Kaggle.com, we can go from there. And if you haven't registered to Kaggle, if it's your first time opening this website, I would ask you to please register and sign up because we're going to be using Kaggle Notebook. And it would be great if you can log in and then save that for your own portfolio. Okay, hopefully everyone registered and we can move on. But if you're facing any issues, just let me know. You can put it in the chat or you can unmute, whatever you prefer. Okay, so let's start from the homepage of Kaggle. So once you log in or register, this is the first thing you are going to see. Now, from here, we can see that there are different options in this ribbon menu. We have the competitions option. So here in this tab, you can find a lot of competition hackathons that you can be a part of, which I would highly recommend. Some of them can be very hard. I believe some of them are maybe some companies, I think based on what I've heard, hold these competitions, and so you can solve their data related problems. We have our data hub, which has millions and millions of data sets. And as I mentioned, you can find a data set for anything you are looking for mainly. I mean, if you want a data set, you don't have to necessarily come in here. You can just in Google Chrome just search for whatever your topic is, dataset Kaggle, and it will bring you. Most of the times, if you don't put Kaggle, this is the first thing that's going to pop up. And then we have discussion forums, but this is the important part I wanted to mention. This is the learning tab. And as you can see, there are multiple courses that you can look into. I saw that there is a data cleaning course, which I would highly recommend, because today we are going to have an overview of data cleaning and very high level set, but we're not going to dive very deep into it. So I recommend you looking into that course. Yeah, that is basically it for this part. I would like to show you Kaggle Notebook as well. So I'm not sure if you've heard or maybe even worked with Google Colab or Jupyter Notebook. They are very similar to Kaggle Notebook in terms of the environment, especially Google Colab, which is also on cloud like Kaggle Notebook. So you'll see a lot of similarities. Kaggle does have some advantages, like having access to all these data sets, so you don't have to just bring all these data sets from outside. You can just access it directly. So if you click on Create and then Notebook, you can create your own notebook here. And you can see, as I said, it's very familiar to other notebooks. You have all these cells. Again, you have code as well as Markdown. Markdown is basically for the text. If you put one hashtag or write something like title, that is the highest header that you can get. If you do 2, it'll be header number 2, so you can go from there. And yeah, for running cell, you can either use this icon here, or you can just do Control-Shift and it would run it. As you can see, it's showing that it's running right now. And here we have where our data set is going to be sitting. So you can you can click on Add Input, and here you can search for all the data sets. These are the ones that I've recently looked into. You can search for anything here, and then once you click on it, it would basically get connected to your notebook, as you can see here. And then from here, you can just copy file path, and then we're going to see in our actual notebook how we're going to be using this file path. Or you can, if you have a data set that's from outside and not Kaggle, you can just click on Upload and then upload your data set. You can upload your model as well. I think that's everything I wanted to mention here, and you can explore more of what each of these tabs do. You can download your notebook, keep it or upload it somewhere, like if you want to upload it to GitHub, but the notebook has a way to directly connect to GitHub and link to GitHub. You can link to Colab, and yeah, so much more. Share it with someone. It has version control. That's a good part of it. And I guess that is it. So now I want to share with you the notebook that we are going to be working with. I will put that in the chat. Okay, good question, Kasim. I hope I pronounced your name correctly. So this notebook is where we have everything that we need to do our data analysis. So you're going to see that, especially because it's in cloud and they have created this environment like virtual computer for us. So we don't have to install anything like we would do if we want to do that data analysis locally. As you can see here, I've already imported everything. I don't have to install anything, any library. I'm just importing it. And yeah, it basically helps you. It's kind of like an IDE, and it helps you to run those codes that you have. In our case, it's the Python code that we have for data analysis. Yeah, and it's also in cloud, so you don't have to worry about anything like using it or anything. It has version control. This is basically the main purpose. Okay, I will put the link here. I hope you can access it. I will also go from incognito and just follow the same path. So in case you're running into issues, so I can help here. So once you open it, you're going to see this copy and edit button. One thing, sorry, before that, as you can see, there's multiple versions. It's going to show you the first version, which is not complete. It's until data preparation. So click on this version 1 of 6, and then click on this version 6, which is the latest one, and then click on copy and edit this version. And it will open the notebook for you. So this is basically like forking it. So this will be your copy. So whatever changes you make here, I won't see, it'll be yours. So later on, you can maybe add on to this project, add more visualizations maybe if you want, analyze more stuff. So yeah. And let me know if you're facing any issues. I'll give you a few seconds to get here. No worries, Gasm. It's okay. We can wait. Don't worry. And as I mentioned earlier as well, I've also included the notebook here in the Google Drive folder that I shared earlier. So if you're having a trouble here, maybe you can try. I mean, you should be able to use here, but I also want to mention, like, if you want to import, not just even now, but even later on, you have the option to import a notebook. So you can basically just download this notebook from here and then just import it to Kaggle Notebook. Okay, if everyone is good to go, I'm actually gonna go back to our slides because we want to talk about data cleaning. Just here at the beginning, before even getting to, yeah, actually let me explain here, and then we'll go to data cleaning. So yeah, here you have the scenario, what we're looking for, what data set we're going to be using. We just imported our libraries here. So the main libraries is the Pandas. So that is the data manipulation library that we have. We have Seaborn and Matplotlib, which are the libraries that we're going to be using for data visualization. We will always have, the first thing that we have to always do is loading our data set. So we load it into a data frame. A data frame is, oh, sorry. Oh, hi, Abraham. Sure, I can definitely summarize really quickly. So currently we are looking into the Kaggle notebook. We haven't started doing any type of analysis yet. I can share this with you again. I'm not sure if you have access to, you can see the history of the chat, but if not, this is the link to the notebook. So if you just put that in the browser, so we're using Kaggle, as I mentioned. If you don't have an account with Kaggle, just put kaggle.com, sign up, and then you can use this link to get access to the notebook that I've created. And from there, I'll go here. So if you click on the link, this is where you will land. Click on version 1 of 6, click on version 6, and then copy and edit this version. And then it will create a copy of the notebook that I have for you. And we're going to be using this notebook to do our analysis of the data set that we have. We are going to analyze the Spotify data set, and we want to find out what makes a song popular. So yeah, we also talked a little bit about, we had an introduction to data analysis, basically of what data analysis is, its application, roles related to data, and that's where we are right now. Okay, I'll continue with the notebook. So yeah, I mentioned importing the libraries that we have. So we're going to be loading a data set into a data frame. So a data frame is basically a two-dimensional table that is going to hold our data set for us. Oh yes, thank you so much, Nader. Yes, I also shared the slides. It's all of it is in a Google Drive folder. There are slides there, the notebook, the cheat sheet. Yeah, thank you, Nada, for the reminder. Okay, so now let's see how we are going to load this data set into our data frame. So here, as you can see, we said import pandas as PD. Well, as PD, if you work with Python, you know that we can give a name to our libraries. That is easier, so we don't have to write pandas every time. We'll just write PD. So that's what we're going to do. We're going to write PD dot and read CSV, and then we're going to put our file path here, and then we're going to assign this to a data frame. We're going to name our data frame. We can name it anything. We'll name it DF, data frame. Okay, that is what I'm going to cover for now. I'm going to go to the slides, explain the data sanity check, data cleaning a little bit, and then we'll come back and we'll continue with our notebook. One thing I want to mention, if you remember, I mentioned where to get the location of the data set. So I said you can click on this icon, you'll get the file path. So you will put the file path here. This is the same file path. And then we use this file path to read this .csv file that we have here. And let's run this. As I said, you can either click on this run button or, oh, sorry, I have to run this first. So I forgot to run this. So now we're going to run the import. And then this one. And then data loaded successfully. Okay. So if everyone is here so far, we'll jump to the slides and talk about data cleaning. Okay, so data cleaning, a very important part of data analysis. As I mentioned, real-world data is very messy, so we can't just use it as is. We have to clean that data. But even before cleaning, we have to do some initial data check. Let's look into maybe how many rows we have in the data set. How big is our data set? Because we've just been given this file. We don't know anything. How many columns we have, how many features, variable we have that we have to be working with and handling. I took actually this example from the course that I mentioned that I just showed that Kaggle has on data cleaning, because our current data set is actually pretty much clean. We don't have a lot of missing fields. So here you can see that this data set that's for the American football games data set has some missing fields, and those are shown as NaN, not a number. So in order to get this first 5 rows of our data set, this is a very common Pandas method that everyone uses. The first thing that they get the data set. So they use the head method. And the head method just prints the first 5 rows of your data set. As you can see here, it says 5 rows times 102 columns, 102 features and variables that this data set has, which is a lot. And you can actually do maybe like head in parentheses, put the 10 or 20, and that will give you the first 10 rows, first 20 rows. We have info as another important method. So this is crucial because it tells us what types of data is in each column. And it also tells us how many non-null values are in that column. So this way we know how many missing values there is because we already know how many rows we have. But there is even a better function that actually gives us how many missing values and fields we have in that data set, which we're going to look into when we get to the cleaning section. Describe is another important method that shows the summary statistics for the numerical columns, things like the mean, the smallest value, the max, the mean, standard deviation, and etc. Now, data cleaning. So I mentioned why we do data cleaning. If we do have all those missing fields and we try to maybe create a chart, it can break the chart. And it can even lead to bad decision making because it can be biased. So we have to really look into how we're going to get rid of those missing fields. Are those missing fields logical there? Are we supposed to have them? Or are these a glitch? Maybe there was a problem in the machine that was recording these numbers and values. Oh, Ibrahim says he can't see the screen. Can everybody else see my screen? Okay.
I can see your screen.
Oh, you can see, but you can't hear me?
No. I mean, I can see
You
your,
can't?
I
Okay.
can see your screen. Yeah.
Okay. Perfect. Is it good to move on?
Yes.
Okay, perfect. Thank you. Okay, where were we? Yes, so maybe there was an issue in the device that was recording the data. So these are things that you have to consider as a data analyst. So this is the method that I wanted to mention that specifically gives us how many missing fields we have in that column. So again, this I took it from that course's data set. So as you can see here, the down is a column, is a variable that we have, and it has more than 61,000 missing fields, which is a lot. But it also depends on how many rows we have, how many records we have generally, right? So these are things you have to consider and to see how you want to handle that those missing fields. So there are one way is basically dropping those those rows that have missing values. And the method that you would use is drop NA. Drops any rows that has those missing values. If you do it on the whole data frame, it drops all rows. But you have to be careful in using this because, as I said, it depends on how big your data set is as well. If you have I don't know, if you have a data set that has 100,000 rows, and then you have like 60,000 rows that has missing values, you can't just drop all that 60,000. Especially when you are working with machine learning models, then your model doesn't have maybe enough data to learn from. So you have to be careful with this. Another thing you can do if you are not going to be dropping those rows is to fill out those missing values. And there are several ways to do this. So one is that, for example, you can replace it with a certain number. It can be 0, like here. So you use fill NA, and then it fills out those missing values. So it replaces all the missing values with 0. Then you can use the mean of that column. So here in the first one, I did the fill NA 0 for the whole data frame. And these three options that we have, mean, median, and mode. Sorry, the last one is a typo. It has to be mode. Here you would, I'm working on that specific column. I'm not saying do this for the whole data frame. As you can see, I have df and then the name of the column and then dot fill NA and then fill those null values with the mean of that column. So again, df column name dot mean. And then we can use also median, we can use mode as well. The third one should be mode. I'll quickly review what these are. There's a high chance you know them. I'll just quickly review. So mean is the same as average. Mean, median, mode, all of these are measures of central tendency. So for mean, as we know, you basically just sum all the numbers divided by the number of numbers that you have. So here we have 5 numbers. So we sum up all of them and divide by 5. So 5.6 is the mean. So if we use this formula here, so this is going to replace all the missing values in that column with 5.6. We can use median as well. So median is basically the middle value of that data set that we have when the numbers are arranged in order. That is important. So if we have 2, 3, 5, 7, 11, as you can see, they're in order. So the middle number is 5. So the median is going to be 5. All the missing values are going to be replaced with 5. One thing to know, which is important to know, is that mean gets easily affected by outliers. So outliers are those extreme values that are not very typical in the data set. So they can really affect that mean. But median is not easily affected because it's the number in the middle. We then have mode, so it's the most frequent value in the data set. So here we have 1, 2, 2, 3, 3, 3. So 3 is more frequent here. So 3 is the mode. But the main scenario where mode is used is actually in categorical data because we can't use mean or median for them. So if we have, for example, genres, different categories of genres, we will get the mode. So we'll see what is the most frequent genre here. We then have data visualization, but I'm going to first go back to our notebook, work through data cleaning, and then we'll come back to data visualization. So if we all can go and open our notebook again. Okay, so we completed this. We'll do initial inspection and sanity check, as I mentioned. Okay, so we have to first see what are the 5 rows of our data set. We just want to get a general idea of our data set. What variables does this data set have? What are we really looking into? So for this, so here we defined our data frame as df. So we would use df dot, can anyone say what was the name of the method that we just looked into? Let me get to the chat section. Yes, thank you, Nader. Exactly, head. So head. And we should get the first 5 rows here. So as we can see, we have 21 columns here. We have variables like artist, the duration of the track, the liveness, the speechiness. So yeah, different things that we can look into and see how these can affect the popularity. Next, we will look into the shape. So shape tells us what are the number of rows and columns. This is another very important method in Pandas. So you can basically say df.shape. So the first number is going to be the number of rows. So we have 114,000 rows or records, and then we have 21 columns here. Or we can even have a cleaner way of doing this and say df.shape, the first index, so 0, and then the second index, 1. And then we can say number of rows is this many, number of columns is this many. Okay, now let's get the technical summary of our data set. So we said for technical summary, we use a method. Does anyone know what method that is? So one, we had the technical summary, which we looked into the data types. And then one was the one that told us what are the statistical summary. So yes, it is info. Thank you. So df.info. So as you can see here, we have the types in this column. And here it says non-null. So if you look into this, there are 3 variables, so artist, album name, and track name, that have one less number than the other ones. So they have 1 missing values in their columns. But there's a better way, as I mentioned, to see exactly the number of missing values here. But before that, let's look into the summary statistics or statistical summary. So we will be using the describe method, if you remember. So df.describe. Oh. So we can see that it gives us information like count, the mean, standard deviation, the smallest number, the maximum number. Yeah. So one thing is, you might ask why we even need this. So this really helps us to see, like, one way it'll help us is kind of see what is the scale of any specific feature that we want. So it helps us with a problem that we can call it the invisible bar, which is related to scale issue. So let's say you decide to, which is what we will see later in the visualization section. So let's say we want to put the variable tempo. We want to visualize that. We want to put that with another feature like danceability in the same bar chart, because their scale is very different. For example, let's say danceability is from 1 to 10, or like 0 to 10, and then tempo is from like 0 to 100. Because it's very different, then tempo might overshine danceability, so we won't really see danceability in the chart. So it really helps with looking into these kind of issues. Okay, we get into the data preparation and cleaning, but before that, I want to ask if everyone is good till here. Let me know if I'm going too fast or if the pace is good, because we have a lot to cover, so I'm trying to get everything done. Okay, amazing. Thank you. Okay, perfect. Thank you, Kesha. Okay, so I'll continue with this. Yeah, we have the data cleaning here now. So we want to check how many missing values exist in each of the column. We saw the method code for this earlier on the slide. So it would be is null dot sum. Oh, sorry. So as we saw earlier as well, as expected, we have 1 data field that is missing in each of these 3 columns, but the other ones are perfectly clean. There is no missing values. If you want to go more in depth, like we can even look into maybe it is not set as NaN, because this is now looks into that NaN that I showed earlier. But what if it is not NaN, but it is like a white space? But we're not going to really look into that, but that is something to consider in your future projects. Because we only have this 1 row out of 100 and I think it was 14,000 rows that we have, we're just going to drop this row. It's not going to really affect us, so we're just going to drop it. So for that, we will use df.drop, as the name implies, drop NA, and done. Now we can again look into the shape of it, or we can use this method here that says what is the maximum number of null values we have now, which we are expecting it to give us 0 because there was just 1 and we just dropped it. And we got what we expected. Great. So another thing we can look into is duplicate values. So the thing is, if we have maybe some rows, some records accidentally got duplicated. If this happens, this can create bias, because let's say there is one track that has been duplicated like 50 times. We can't really, it's not fair to compare this track to the other track that exists only one time in the whole data set. Because maybe especially if the popularity is high for this track, so it kind of can create that bias of how its features are related to popularity. So that is why we look for duplications as well. Here I have written all the code already, so I will just be running these cells. So we don't have any duplicate rows, which is great. But if we did, we would have used drop duplicates, and this would have gotten rid of all the duplicates except the first occurrence. Shape, yeah, so no change. Okay, we get into exploratory analysis, the fun part, which is where we're going to create all that visualizations. First, just to explore the data set and see how it looks like. So I will go back to our slides. Okay. Okay, data visualization. What is visualization in the first place? So basically, visualization helps us translate that giant number of rows that we saw into charts, visualizations, a story basically that the human brain can easily interpret in the maybe in the first few seconds of seeing it. We can use different colors, we use different shapes and patterns in order to show the trends that we've seen maybe pop out for the stakeholder, let's say, or whoever is viewing our visualization. So the advantages is that it grabs the interest, makes the trends out and outliers instantly visible. It's easily shared across non-technical teams, but it can negatively affect what we want to do if we don't do it right. So poorly designed charts can create bias, can be confusing. So we have to really be careful, and we are actually, hopefully if we have time, we're going to look into some bad visualizations and how to avoid being like that. So let's look into some basic charts that we are going to be using some of them today as well. So we have the bar chart, which we all are familiar with. They're the easiest way to compare different categories, like, for example, which Spotify genre is the most popular. So we can use bar chart for that. The x-axis shows categories, and the y-axis shows the count, the values. And there are different types. There's horizontal type, there's stack type. We have line charts. So line charts are mainly for timelines in order to track changes over time, but it is also used for showing basically that trend, right? That ups and downs that are happening. We have pie charts. So pie charts are these round charts that are divided into slices, and each slice represents percentages of a whole. So it really shows how different these parts contribute to the whole, are a part of this whole. But one thing is that you have to be careful in using pie charts, because sometimes really it can make things complicated and it might not be the best choice. So use that with cautious. We have scatter plots. So scatter plot is how we find the relationship between two different numbers, two different variables. If we want to know, for example, does having a high danceability score mean that a song gets a high popularity score, we would use a scatter plot. We basically plot them against each other and see if there are any patterns that we can notice. We have histograms as well, which tells us what is the shape of our data. We use this to see what is the distribution, basically. Is it does it have a normal distribution? Is it maybe skewed? Is it right skewed? Is it left skewed? So yeah, we can use it for this purpose. So basically it groups all these numbers into different bins that we're going to have. It's called bins. Some advanced charts here. We have heat map, which we're going to be using today as well. It's a very important chart. And they actually help analyze multiple variables at the same time, and in order to basically uncover deeper insights, see if they're correlated to each other or not. We have box plots. So this is also a great way to understand how our data is spread. It is also mainly used in finding extreme outliers. So this one does not have it, but sometimes you would see that there are like dots at the end here. You would know that, yes, we have outliers here. If there are too many, it would tell you that it's basically our data set does not follow a normal distribution. Okay, let's move on. We have tables as well, which we're familiar with. We also have graphic maps, and they are basically used to display the geographic data on a map. They can show, basically location data. For example, they can show, here we have the core pleth map. For example, they can show if, I don't know, let's say which countries showed more cases of COVID. So the redder the country on the map, the more cases that was there. And lastly, we have the dashboards. So this is kind of the ultimate end product of a data analyst work, the reporting part. So this is where we combine multiple visualizations that we created into a single canvas, into a single interface in order to show to the stakeholders. This is what mainly the business side would want to see. You can create dashboards using different tools as well. For example, like Power BI is one. You can even use dashboards for the real-time data, so it would change in real time as the data is being analyzed. So generally speaking, the best practices for effective data visualization is audience-centric design. So considering the audience when you are creating those charts. If the audience is maybe more technical, so consider creating more advanced charts. But if they're not, maybe more simpler charts is a better option. So design clarity and consistency is another best practice. So choose the right chart for what you want to do. For example, I earlier mentioned that pie chart might not be the best choice sometimes, and actually we have an example of when it's not in the upcoming slides. So use the right chart to actually show what you want to show. Providing context is also very important. Be sure that you are labeling your charts, you are including the titles. The data source acknowledgement is also a very good and important add-on. Before moving further, I will move into the rest of our notebook. If everyone is good to go, we can continue. Okay. In case you put something in the chat, maybe I don't see it, feel free to unmute. Okay, I will continue with our exploratory analysis. As the name implies, and as I mentioned earlier, exploratory analysis is basically just exploring the data set that you've been given. So playing around with it, seeing what the data set looks like, what things can I get out of this, are there any insights that I can get out of it? How about if I compare this variable with this variable or that variable with that variable? So basically playing around with the data set. We will be looking into the distribution of popularity. Of course, there are more that you can do. These are things that we're covering today. We're going to look into danceability vs popularity, how they're related, or energy vs popularity, how the energy of the song is related to popularity. Does higher energy song mean that it is more popular? Genre-based popularity. We are going to also create a correlation heat map where we're going to look into where it's going to better help us to see how all these variables or all these properties of an audio are related to each other. We are actually also, which I haven't written here, but we're also going to look into how the popularity of how the artist is related to the popularity of the song. So which artists are maybe more popular. Okay, so let's start with the distribution of song popularity. Okay. So this one I'm gonna write from scratch with you. And later on, I've included most of the code, maybe some parts that needs to be filled out. But the first one, we'll write it together. So first, when creating a chart, we always try to give a size of how big we want the figure to be. This really helps in keeping things clean. Sometimes it can be maybe big and it can squeeze things. So just avoiding all those situations. So PLT, which is what we defined for our Matplotlib library, if you see at the top. So PLT dot, you would write figure, and then you give the size that you want. So we are going to give 10 inch by 4 inch. So 10 inch wide, 4 inch tall. You can also there are more arguments that you can pass on. You can maybe pass on the resolution of your computer. So that way you can even be more sure that nothing will get messed up. Now we are going to create the histogram. So we mentioned already when explaining the histogram that it helps us with learning the distribution of our variable. So that is what we're going to do. We're going to create the histogram. So we would do sns dot hist plot. So sns is our Seaborn, from our Seaborn library, the name that we give. Data, we pass data. We have our data frame. So for our x-axis, we will pass the popularity variable. We mentioned that the different parts in histogram is called bins. So here I'm going to give bins of 40. So the reason is that if we give 5 bins, the chart is going to be too blocky. And if we give maybe like 500 bins, so the 5 bins is going to make us really lose the shape. So we're not going to see all that, the actual distribution. If we give 500 bins or like 1,000 bins, it becomes very noisy and like cluttered. So we picked 40 to have that balance. Now we just like guessed a number. However, there are methods or mathematical formulas in order to calculate the perfect number for the bins. There's, for example, the Friedman's rule that can be used, and this is mainly useful for skewed data sets. So yeah, if you want, I'll encourage you to look into those, but for now we're gonna manually give the number 40. We can even give the color, so we'll just use purple. Next we want to, so okay, if we just go with this, I want to just show the difference. Maybe we'll go step by step. So same as how we have like print, and then we give the text inside in Python in order to print that out. So we have to have a way to print this this chart out. So we will do plt.show. Oh, let me check why we were getting. Oh, sorry, I missed a. Okay, there we go. Okay, so if you also have the same issue, you have to add this equal sign here, which I missed. Okay, so as you can see, we have our histogram here, but we can make this histogram better because as you see, there are no titles here. yes, we have the popularity and we have the count here, but we can even make those better and more descriptive. So we want to give the title for our chart. So we'll do plt dot title. Let's say this is the this is the distribution of song popularity on Spotify. Now, let's give the label for the x-axis. So we say x label. Its popularity score, which is from 0 to 100. And then plt.y label, which is the number of songs. So here it just told us count, but we want to be more descriptive in what we want to say. So number of songs. So now let's run this again, and as you can see, the labels change. The title, now we have a title. We know what this is actually showing. So this is very easier for a viewer. If they see this the first time, they will know what it is. So we don't have to really explain it though. Okay, one question maybe we can ask here is, what do you really notice from this chart? What stands out to you? Look at this. What is the tallest bin that we have? So basically, from here, we can see that actually most of the songs, yes, exactly. It's lots of unpopular songs. So most of the songs that we have actually have a popularity score of 0, which is interesting, but also expected. Okay, I've also put these cells here for you to fill out if you want, based on whatever we're discussing. So the insights that we get from each visualization that we're creating. One thing that is a good practice is when you are creating your notebooks, try to create a report. So make sure that you have good headlines, you have it's clean, you have a conclusion for different parts, you have explanations. So it has to show your whole work, show what the explanation for each step, what you are doing, what did you get out of this step. So always try to add those parts. I'm also going to complete this at the end. I'll put the insight and all that as well inside the conclusions. So if you want, you can go back again to my notebook, maybe by tomorrow. And then if you want, you can get the full notebook from there as well. For today, I just wanted to keep it like this. So maybe you guys would want to add your own insights. Okay, now let's look into the distribution of danceability and energy here. So here I've already written the code. So one thing I wanted to mention here, so you see that we have a set theme. One interesting thing is, so if we do this, this is going to change the theme of the charts from this cell onwards. So whatever charts you create, it's going to have this theme where its style, its background is going to be dark grid. If you want all of your charts to have that theme, you can basically put this at the very top of your notebook. But I want to just show it to you here. I'm going to just run it, but then I'll go back to the normal white grid that we have here. So here, the difference between this and the histogram that we created is that one thing I want to show you here is that you can put more than one chart next to each other. So here we just have one chart here, but you don't have to necessarily have one cell for each chart. So have one chart and the next cell will be the other chart. You can put them together. So for that we use, sorry, not this one. We use subplot. So here the subplot is saying that I want one row, each row having two charts with this size. Here we define both of our histograms, so danceability, and then the energy, so the distribution of these two. If we run this, okay, so you see we have the distribution of both. We have an almost normal distribution for danceability. For energy, it is skewed. We have more energy towards one, so most of the songs are actually energetic. I wanted to mention one thing. Oh, yeah. So as you can see here, when we set the theme, so we changed the background here for us. Here it was white. Here we have this dark grid. There are several other background, the styles as well that you can use. I'm just going to switch to white and just continue with that. Okay, now let's look into, we looked into distributions. Again, you can add more of your own later, but now let's compare things together. So now let's compare danceability to popularity. Are they related to each other? We're going to be using scatterplot here, because we mentioned earlier as well that scatterplot is what we would use to show, to compare two variables together. So for x-axis, you would put danceability. For y, popularity. And now let's run it and see what we get. So we basically just got a blob. It doesn't really show a trend. It doesn't really show that there is a correlation between the two. One thing I wanted to mention is, as you saw here, we sampled 1,000 of them, because if we take all of our data set and then plot it like this, it's just going to be a mess. So we wanted to look at a random sample. Another important thing here in the code is this alpha argument. So as you can see, it has been set to 0.6. So this is how transparent we want those points, those dots on the chart to be. So currently 0.6, which is a good balance and something that usually set to 0.6. It's because it has that little transparency, but it also has this ability to, that when two dots are on each other, it becomes darker. So it has that balance. I can change it and you can see what happens if it goes lower. As you can see, it became much more transparent and a little bit harder to follow. So we'll just put it as 0.6, and we put the color here as well as teal. So we use the scatter plot method here from the Seaborn library to create this. We're creating something similar here, but this time for energy vs popularity, to see if there's any relationship between these two. And we see that here as well, there isn't. Again, we don't see any trend. Maybe I'll change the color for this one so it won't be similar to the other one. I just changed it to red. So here also we see that we don't really have any correlation. Okay, now let's look into genre and popularity. Genre is something that might be related to popularity if you think about it. And before that, maybe let's look into how many genres even we have overall. So we use this n-unique method. So if you run this, you'll see we have 114 genres in this dataset, which is crazy. Okay, now let's look into this code that we have here. So I've already written the code. So we are using this method called group by here. And we are using group by to group the genres. So think of this as putting all the songs that we have into different baskets, into different bins based on their genre. So that is what group by really does. And then after we group them into different baskets, we can then do other things on it, like get the mean. And as the name implies, as we know, so this is just going to get the mean to calculate the average popularity score of that specific basket. And finally, we also have reset index, which is just something for cleaning up the table format, because this returns a table and this genre pub is actually a table. Then we would sort the values from the highest to the lowest so we can get the top 10 popular genres based on the popularity. That's why we said by popularity, and don't do it in ascending. If you do it in ascending, it's going to be the other way around. We're going to get the top 10 lowest popular genres. We will create a bar chart for this. So we use bar plot from the Seaborn library for this to map our categories. And yeah, as you can see, the data that we have is the top 10 genres that has been sorted. If we run this, we see that we have these genres as top 10. So we have pop film, we have K-pop, we have chill and sad. So yeah, let's, I guess, move on to the next one. Hopefully we're not running out of time. Okay, so this is an important part that we get to, the correlation heat map. So as I mentioned, the correlation heat map is this map that basically helps us see what is the correlation between different variables. So it kind of puts everything together, shows us what are the correlation between them. So it's easier to compare them. And it's easier because it also does this through coloring. So here we have all the numerical columns that we want to compare with each other. And here we again have the size set for our canvas. And now we want to create the heat map. So for this, we're again going to use the Seaborn library. So we would do cns.heatmap. So we would pass the data that we have. So numerical calls, that's what we named here. And then dot correlation. Oh, sorry. And then annotation true. So we want annotation true so that it puts the number on each of the fields. You will see what I'm talking about. And then we have CMAP cool warm. That's how we want the coloring to be. Go from cool to warm. Warm showing that they are correlated, white showing that they're not, and white showing that they're not correlated, and then the blue showing that they have negative correlation. So if one increases, the other one decreases. And then we do FMT here, 0. Sorry, this has to be equals 0.2F. So this is for the numbers. And 1 and Vmax. So we want the scale to be from -1 to 1 for showing that correlation. So if we run this, there's something wrong here. I have to put this in the quotation marks. So yes, as I mentioned, this is for the number of decimals that we want to have. So 2 decimal points. Okay, sorry. I should put this also on the. Okay, let's see what we got here. Oh, I have a spelling error here. It has to be 2 N's. That should work. Okay, there we are. Oh, I think there was an issue here. So this has to be -1. The Vmin, I accidentally put it as 1. Okay, there we are. Okay, so let's look into this one, this heat map that we have here. So as you can see here, the diagonal line here, we have all red, which is expected because if you track them, so this is energy against energy, danceability against danceability. So of course their correlation is going to be 1. They're the same thing. They are, of course, highly correlated. But one thing we want to focus on is how these variables are related or correlated to popularity, because that's the question that we're trying to answer, right? So if we look into it, we have danceability that is above 0. Energy, not at all correlated. And actually duration is has a negative correlation. We have loudness, little correlated. And then we have tempo, as well as explicit language, which are a little bit correlated. So, okay, this is good information. So now we know what variables are not correlated at all. So we're not going to be spending time on those. Okay, for this part, now we're going to look into how the artists help with the popularity of the song. Okay, so we're going to start with... Okay, one thing to know about this variable is that this is also mentioned in the datasets page as well, that if you go look into here, it says artists. So the artist names who perform the track, if there's more than one artist, they're separated by a semicolon. So this is an issue, and we have to resolve that before we move on. For that, we are going to add one more column to our data frame called artist count. And basically, it's going to show how many artists have contributed to that track. And we're going to do that by counting the number of semicolons and then adding a 1 to it. So if there are 2 artists, there's 1 semicolon in between them. So 1 semicolon plus 1, we have 2 artists. So let's run this cell. Now, let's describe it, because we want to see, has this column been added, but also what is the maximum value, what is the minimum value. Of course, minimum value is going to be probably 1. But let's see what is the maximum value for it. So df dot describe. So if we go at the very end, yes, artist count has been added. Maximum is 38, which is really interesting. So from this, we can see that there was one song at least that had 38 artists on it. So that's really an interesting thing that we found out. And actually keep this in mind, because we're going to see something in a little bit related to this. Then we're going to be exploding it. What does this mean? So we're going to be using a method called explode. What this is basically it takes that row that has those multiple artists and then duplicates it, where each row that is a duplicate will only have one artist for that track. So we're kind of not expanding necessarily, but yeah, as the name implies, exploding it. So we're like dividing it, kind of. So each artist will have its own row. So everything is going to be duplicated, the track name, all the features, except the artist name. So let's run this. Okay, perfect. Now what we're going to do after exploding, which we did it based on the semicolon that we have here, we're going to be stripping it. So what this means is that because we don't know how these artists were put together in one field with all those semicolons, there can be spaces between the semicolon and the artist name, or maybe there isn't any spaces, so we don't know. But in order to be cautious, we want to get rid of those spaces before and after the name of the artist. Because if let's say we have 2 tracks that both have 2 artists in them, and the common artist between them is, I don't know, Celine Dion, let's say. In one of them, there was a space before the name of the Celine Dion, so when we did the explode, one row now has Celine Dion with a space before it, but the other one did not have it. So after exploding, there is no space before name Celine Dion. Python is going to see these as 2 different artists. It's not going to say, okay, it's Celine Dion, so same artist. No, it's going to look at the whole string, and because it sees that difference, that space, it's going to consider them as 2 different artists, but we don't want that. So we do strip. We run that, and okay, let's see actually this exploding, how did it really change the size of our data set. So before we had this many rows, we deleted one row, if you remember. That's why it came down one from the 114,000. And after exploding, now we have this many. We have more than 158,000. So that's a lot of change. Okay, now after we got our data set ready, also one thing I wanted to mention, I put it as a note here as well. Because after exploding, as I mentioned, one song can, as I mentioned, one song can be repeated, right? One song can be repeated. It's just going to be the name of the artist that's going to change. So the variables and the features of that song are going to be repeated. But we don't want that to affect, it's like a duplicate row, as we mentioned earlier. We don't want duplicate rows. So this is going to be very similar to that, and we don't want that to create a bias in our analysis. So what we're going to do is that for other analysis, we're still going to use our main data frame that we had, only with the addition of the artist count. That's okay. But this DF exploded that we have here right now, we're just going to use it for this specific analysis that's related for the artist. So we're going to find the top 15 popular artists here. So I've already written the code here. So as you can see, we count the number of, so I've written here, so we filter for artists who appear on at least 15 tracks to keep it statistically valid. So we're going to count how many times these artists appeared, because again, we're kind of trying to avoid that outlier. So we don't want, if one artist was very popular, but their popularity was not really consistent, so we don't want to include them. So we're just going to look for artists that have appeared more than 15 times. Okay, so that's that. And here we, again, use group by, as you can see here. And then we're going to be sorting them. So we're grouping them based on the popularity, and then getting the mean. And then, again, sorting them. Basically what we did earlier as well for another feature. And here it's, again, the same thing, creating the bar plot. I guess that is it. So let's run this. Okay. So here we have the artist name against the average popularity score. So these are our three top artists here. So Radiohead, The Neighborhood, System of a Dawn. As you can see, we have actually a good thing that we saw this morning, because you might see it as well. So in the new version of this method, they have added the hue. So you can also add that to get rid of this error in the bar plot. So you can add, so hue dot artists, and then this should fix the issue. There you go. Okay, I guess that is it here. Before going to explanatory analysis, I wanted to look into one more thing. So we want to see if there is a collaboration effect, meaning that is it possible that the tracks that have more than one artist in them are more popular than those that are a solo singer? So we're gonna create the line plot for that. As mentioned, line plot is also used for showing the trends. So we're going to be using that here. Again, here we have same thing, grouping by the popularity, getting the mean. But let's create the bar plot itself. The line plot. So we would do SNS dot line plot. So this is the method we will be using. Data collab trend. For the x-axis, we will be using the artist count. Our y would be popularity. want to put marker, we'll put O here. We'll give the color of our line to be purple. And then how wide we want the line to be. Okay. Hopefully there are no errors and we can run. Okay, perfect. So you can see that there is a lot of ups and downs here. And you can see it goes all the way to 30 something. If you remember, I showed that the max value for the artist count was 38. So it's gone up to 38. But that's really not realistic. So that's really an outlier for us here. That's why we want to really limit this graph. So it only counts for the, let's say, 6 artists. And then we see how it affects the popularity. Because that's normally what we've seen in the real world as well. So let's do that. We will use a method called xlim. So 1 and 6. So here we would limit 6 artists to avoid those rare extremes. If you run this, so you would see now we are just focusing on that 1 to 6 artists. And if you look closer, you would see that first the 3 number of artists has higher average popularity score, and then the 2 number of artists. So that is definitely an interesting find, and we are going to include it in our report for our stakeholder. I guess that is everything here. I guess we can move on to our explanatory analysis. Okay, if everyone is okay to go. Sure, I saw a message in the chat section that says send the video link. Sure, if you want, I can send I can email the link to all the participants. We are thinking we might also upload it to our YouTube channel, but if not, I can definitely send the link to everyone. Okay. Now let's move on to explanatory analysis. So we have about 20-ish minutes. So I'll quickly run through this. I've already written the code for all of these. So I'll just be running it and giving a short explanation, but you can look into it further on your own. I've tried to put comments as much as possible, but yes, you can definitely look on your own. If you have questions, you can search or let me know later on. As mentioned, in explanatory analysis, now we want to show what we found to the stakeholder. So we want them to exactly see what we want to show them right away when they look at it. So that's why we're going to try to highlight some things, highlight the main things that we found. In exploratory analysis, for example, there wasn't any occasion where we were very strict in like, I want to show you this, because we were exploring. But here, it's not like that. So you will see what I mean in a second. So, okay. We saw in the correlation, in the heat map, that there were specific variables that had a somewhat positive relationship with, correlation with popularity. So those are the ones that we've included here. So here we have put that, this can be maybe something that the stakeholder wants. I just took a number. I said if the popularity score is more than 80, so those for me are the hit songs. Those are the ones that I'm targeting right now. Create the graphs around this idea. So I've created a bar chart here, and I've said that, okay, I'm showing the hit songs here with green color because I want them to be highlighted for my stakeholder. I want these columns to stand out for my stakeholder, and the other ones are grayed out, as you can see. So I'm basically saying that, and I'm giving a title that's even more descriptive that says what is this showing. So here I'm saying what separates top tracks from the rest. So what are the main components of the song? So danceability, I can see that the hit songs have a higher danceability score compared to the average songs. Energy is higher in hit songs. Valence is higher. Valence is basically, you can also, again, look into this if you want to know exactly what each feature is referring to. But valence is basically how happy the song is. Acousticness. So acousticness is lower. Therefore, if you want to create a hit song, try to go towards using more instrument, maybe not acoustic. So that's what we get from this one. Then we have, okay, so here we have again the hue issue. So if you want, you can fix that later. So here, okay, one thing to mention, if you remember in the heat map that we saw, we also saw that tempo had a correlation, so 0.01. Not that high, but still a correlation. So we want to show that as well. However, again, if you remember, I'll go back again. So if you remember, I said one of the reasons we create that summary statistics using describe, if I can find it, yes, using describe was to kind of see the scale of our variables. And I gave you the tempo example. So this is where that is being used. So the scale of tempo is different than all that danceability, energy, valence. That is why if we put them in the same graph, it is kind of going to make the danceability, energy, valence, and acousticness not visible. So I can actually try and show that. Let's see. Let's add that. So this is what I'm talking about. So the scale is different. The previous ones, I think they were between 0 and 10, if I'm not wrong, but we'll go back to check, or 0 and 1. But here, because the tempo has a very larger scale, so that's why we can't see the danceability, and where they're like very small now. So I created a separate plot for that one just by itself, so it won't affect this like this. Yes, from 0 to 1. Okay, so here we have the plot for the tempo. And we can see that the tempo for hit songs is actually a little bit lower than the average songs. So, and it has the average of 119 BPM. So maybe we can recommend them to maybe go for a song that has a tempo that is around this number. So the line plot that we had for the artists, it actually showed that the tracks that have 2 or 3 artists are more popular, so compared to solo tracks. So we want to show that as well. We actually define a function here that basically says, okay, if the count of, because we want to put this label on them, we say if the count of the artist is 1, put that tag solo. If it's 2 or 3, put power collaboration, 2 to 3 artists. If it's more than that, put mega group, more than 4 artists. Sorry, I see a question in the chat section. Why not represent tempo on the same chart? Yeah, as I mentioned, they have different scales. So we saw in the describe, or we just actually put tempo on the same chart. We saw that all the other features get minimized because they have different scales. So yeah, that's why we don't put them on the same chart here. Okay, back to this chart. If we run that and we put a different palette here as well, so we can define our own palette or use the existing palette. Here we defined our own palette because we want to force, so we want to basically force our chart to highlight the group that we want, which is 2 to 3 artists, with the color that we want, which is green in this case. And the other ones, we want them to be gray. As you can see, they have the same color. Okay. So as you can see, here, this is the one that we want to highlight for our stakeholders. So that's the one highlighted. And we give a good title that actually, it's kind of like a report. It tells what it is. So the collaboration premium, multi-artist tracks outperform solo releases. So we kind of put the conclusion there as well. Okay, and here, because we didn't see this before, but this is basically putting these numbers and these data labels directly on top of the bars. So we can compare the numbers as well, which we can see this is higher. So we have to use a for loop for that in this case. We have one more chart, and that is the top 10 genre. I mainly wanted to show this to kind of see the difference between explanatory and exploratory analysis. We already saw the exact same chart in exploratory analysis. We still used a good color palette for that as well, which was going from blue to red, showing blue more popular. But if we want to, let's say, sorry, I should have changed the title for this to kind of put like top 3 genres. But if we, let me just change this actually. So if we want to, highlight maybe 3 genres, maybe we want to highlight 5 genres, or maybe we want to just highlight all the 10 genres. We can do that like this. I just wanted to show how in explanatory analysis, we focus on the part that we want the stakeholder to see. That is everything basically. So you can write the conclusion. I'm going to add it to my own notebook. But if you want to give a recommendation based on everything that we saw, so it would be to focus on producing an upbeat, high danceable track in a top performing genre like pop film or K-pop. Keep acoustic elements to a minimum, and aim for a tempo that is around 119 BPM, which is that sweet spot that we found, and also bring more than maybe one artist to the track for collaboration. That is it with our notebook. I'm going to quickly go back to our slides here. There are a few things I wanted to discuss. Okay, let's see. I'm just going to open the chat. Okay, no questions. So I'll proceed with the slides here. So we saw I mentioned the best practices for effective data visualization, and we saw that we tried to include this in our visualization, like providing context or clear design or audio-centric design. But we want to see some examples of bad data visualizations. One can be misleading graphs. So graphs that have a truncated y-axis, or that have an improper scaling, or there are cherry-picked data. So an example of a truncated y-axis is actually from an ad for Chevrolet that was, I think, in 1993, I believe, which claimed that more than 98% of all Chevy trucks sold in the last 10 years are still on the road. If you look closer, so this is an example of a truncated y-axis. If you look closer, you will see that the start is not from 0, but it is from 95% to 100%. And this, in the first look, it shows that, wow, Chevrolet has a much higher number, almost twice as Toyota, almost, 10 times as Nissan and Datsun, which is misleading, because if you actually plot it from 0, you'll see that it's not that different. So this is one example of misleading graphs. The other example is this graph, which is for annual global ocean average temperatures. The thing is, so if we look at the first one, it doesn't show that much difference, right? It's just a little bit of highs and downs, which is not that significant. But look at the temperature, the scale that we have is from 0 to 20. But we have to look at what we are analyzing, what we are looking at here. We're looking at the temperature, average temperature. Even the slightest change in the temperature can affect global warming, can affect the global temperature. So we can't really look at this I guess, topic the same way as we do for the other ones. So we have to look what is the difference if we put into the proper scaling, how it would look if we put from -1 to 1. As you can see, there's a lot of ups and downs, and it has actually increased. So you can't just look at the one in the left, which is misleading, and say, okay, there weren't a lot of changes in the global warming. The temperature did not increase. As a matter of fact, it did. Even 1 degree is a lot. For cherry-picked data, so this is one example that we can give, which is the UK national debt. If we look at this, first thing we'll see is that, okay, so the national debt for UK is increasing. And because it's the first look, we're not really looking into the years that this graph is showing. So it's showing 1995 to 2016. We might think that, okay, so it has really increased, and maybe this is the highest point in the whole UK history. But if you look at the whole graph, it's actually just a small portion of it. So it's about from here to the end. But around in the 940s, it had a peak that was much higher than 2016. So it's not giving us the full picture. Inappropriate chart types, which I mentioned earlier about pie chart. So if you have many categories, do not go for pie charts at all. It can be very confusing, very hard to read. You can't really distinguish between the few categories that we have here in the first glance. So go for something that is more appropriate. Go for a bar chart here. We have a horizontal bar chart here, which is like in the first time we lie our eyes on, we'll see that the general consumer web has the highest number here. Be careful of overcomplicating your visuals. So here you can see that there's a lot going on, and we don't really know where to look at. We don't know what to get out of this graph. Even the dates are not so user-friendly here, as you can see. There's just a lot going on. If we clean this up, we can get something like this, which is easier to read, more understandable. We can actually see what is telling us. As you can see, it is much better. It has much better representation of the dates. And we can actually see, and it has all this title and everything, so we can actually see that it has how the sales over time by purchase type was actually how it went up, how it went up and down. So we have lack of context. We already talked about how important to put labels and titles. You can't just give a graph like that without any labels. So this is, for example, this is 200, but 200 of what? $200, or is it 200 numbers? Like, is it count? But no, if you give a label, now we know that it is actually revenue. It is $200,000. And here, instead of ABC, we have a proper label for them. We know it's talking about months, and we have a title for our graph. This is another lack of context, but it's a little bit different. So here we don't have if in the first glance you will see that the number of serial killers in this country is just a lot higher than other countries. But you also have to look, this can also be misleading because you also have to look at the background here, the context, which is you're not really considering, or you're not mentioning how the population is different among these countries. We have poor use of colors. We already discussed this going through our notebook, but you don't just want to use colors for the sake of colors. So you want it to actually show something. Maybe, as we saw in the correlation map, in the heat map, maybe it can be something that goes from like darker to lighter color. So that can help, because in the first glance we'll see, okay, like for example, in that situation, the darker, the more positive the correlation. Or in explanatory analysis, we saw that we highlighted the ones that we wanted to be highlighted with green color. So here as well, we want to show, we want to talk about China, so we highlighted that part. So at the end, I just want to mention a few things of where to go from here. Now you kind of know the building blocks of data analysis. You know how have experience cleaning the data. You know what exploratory analysis is, how it's done. Definitely, I encourage you to go further into it. You now know what is the purpose of explanatory analysis, how it is different from exploratory analysis. You know how to use Kaggle Notebook. You know what features Kaggle has. So these are really important. But if you want to go further, maybe you want to go into machine learning, or you want to go into data science. So I encourage you to learn the fundamentals of these fields. So statistics and math are important, especially statistics when it comes to data science. So look into more, to make use of the features that Kaggle provides, like the competitions in Kaggle Learn. So definitely go through the courses that they have, see what you're interested in. They have courses on machine learning and data science, and once you finish them, you'll get a certificate, and you can put that on your resume or on LinkedIn. Yeah, explore the world of machine learning if you're interested in it. Look into scikit-learn, very important library in machine learning. Look into different models. And just make use of the free resources that you have, like the Kaggle courses that I mentioned, but also LinkedIn Learning. If you haven't used it yet, you do have free access to LinkedIn Learning as a Conestoga student, so definitely make use of that. Before going to Q&A, I actually had a few. If you go back to Mentimeter, I actually have a few questions that you guys can answer. Now let's see. It's about bad data visualization. So let's see if you can tell what is wrong with these charts here. Yep, exactly. The y-axis is inverted. And because of that, in the first glance, it feels like, so it's the gun that's in Florida. It feels like, oh, okay, we had a drop in here in the 2000s maybe, but that is not the case. So yeah, this is not real. This is definitely misleading, not showing what it has to show. Yeah, it does look cool. Okay, we're good with this. Let's go to the next one. And these are from real scenarios. They have been presented to real audience before. So yep, exactly. Yep, definitely doesn't add up to 100, which is the whole point of a pie chart. But yeah, I guess, yeah, sources are also opinions, so it's not maybe that legit. Um, yeah, great. Okay, let's go. There's two more. Truncated y-axis, that is right. So it started from 34 instead of from 0. Yep, that is completely right. Yep, definitely. Okay, great answers. Okay, let's go with the next one, the last one. Here, this is a little bit tricky because there are two issues here. Yep, that is one for sure. Yes, that is right. So the second issue here is here. So 9%, 8.6%, they're both on the same level, while 8.9 and 8.8% are actually lower. So that doesn't really make sense. That is it for labor is misspelled. Oh, I guess I guess that's right. Oh, okay, amazing. Thank you so much for participating. Just going through the last slide here, our Q&A. If you have any questions, feel free to unmute or put it in the chat. If you want, I can even stop the recording. We can chat about anything you want, maybe this workshop, maybe you have recommendation, suggestion how to make the workshop better, or just chat about anything, about, I don't know, about co-op, about anything that I've done. I'd be more than happy to chat. I also wanted to put our social media pages here. If you haven't, if you're not following them, I would encourage you to do so to know about the upcoming workshops. But you probably, if you are a member, you definitely are getting the emails. So that is that, and yeah, that is all. Thank you so much for joining us today. Let me stop sharing. So there's a question in the chat that with the advent of AI, do you think that it's difficult to find junior analyst job now? That's a good question, and a question that a lot of people going into this field are concerned with, for sure. I still think there are positions. When I was looking for co-op, there were definitely positions. I got 2 interviews, and one of them an offer. The other one I actually couldn't even go to the interview because I already had an offer. But both of them were related to data. One was data analyst role. The other one was also related data analyst for making Power BI and dashboards. So I think there are definitely jobs out there. It might become a little bit harder for sure, but I think if this is something that's very interesting to you, again, building those projects on your own, participating in the competition, so having, building up that credibility for yourself, contributing to the dataset repos that are existing and all, those really help. And again, if you're interested, maybe if you have a co-op semester coming up, maybe look more into those roles. So a lot of the companies that do hire co-op students tend to, if they're satisfied with your work, tend to rehire you after graduation. So that would make things easier. Of course, like any other field in not just in tech industry, any other field, AI has impacted it, but I think it's not it is still, we can still find those jobs. Thank you so much, Matushi. Thank you. I hope I answered your question, David. Thank you. You're welcome. Okay, great. there are no more questions, I will stop the recording, but I'm still going to be here in case you have further questions, but also feel free to leave. Again, thank you so much for joining today. It was a pleasure being here and sharing what I've learned so far as a student in computer science with you.